So to begin with the CLACCM main course content, first we will do some basic discussion as an introduction of it. So starting off with the emergence of VoIP, we talked about what is analog, digital, and what were the problems in analog signaling, digital signaling, and then we moved to VoIP. Then what were the advantages, disadvantages with both analog and digital, and then the advantages of VoIP over analog and digital. So starting off with the overview of that, just to recap, what was the benefits of emergence of VoIP? So with voice over IP, there's a reduced cost of communication because not all calls are charged. There's a reduced cost of cabling. Mobility, you can take your phone with you, so you have a capability of taking your phone, your extension, or your profiles. So mobility is that. Then IP soft phones can be used with the emergence of VoIP. Unified communications, email, voicemails can be used. So these are some main advantages or benefits of VoIP. Then in unified communication, there are different types of servers and services which can be used. These are the main components of unified communication. CME, CUCM, Unity Connection, CUCM IM and Presence, Expressway C and E, Cisco Meeting Server, and UCCX or Contact Center. So these are the main components of unified communication used for different purposes. Then PSTN components. So in PSTN, there it comprises of different components and connection types, different devices, and so on. So the main components of PSTN are analog telephone, local loop, CO switch, central office switch, trunk, private switch, digital telephone. So we can see here in the picture, we have an analog phone connecting to the PSTN cloud, and specifically with the central office switch via a local loop. So analog telephone, local loop, central office switch are the components of PSTN. Then the PSTN cloud is also connected to a private switch. So a private switch or PBX is another PSTN component via trunk. So trunk is another component and digital telephone. So these are the all PSTN components. This is another elaborated picture of the same. We have analog phone, we have local loop, we have PSTN cloud in which we have different central office switches connected to each other via trunk. Then we have trunk link connecting PBX or private switch and private switch connecting digital phones. So PSTN, public switch telephony network, has a very important concept of the numbering plan. So we discussed about what are the numbering plans. PSTN numbering plan is based on a standard E.164. E.164 is the standard given by International Telecommunication Union. This is an international numbering plan created by ITU, International Telecommunication Union. So in this standard, there is a country code, there is a national destination code and subscriber number. This comprises of a E.164 standard number. In E.164, the maximum number of digits a number can have is maximum 15, which is for international numbers. The authorities that follow this standard is NANP. NANP stands for North America Numbering Plan. They follow this standard. So in NANP, there is the segregation of the numbers or different codes like this. There is country code, there is area code, central office or exchange code, and station code, which is based on the E.164 standard only, but just it is more segregated in this form in NANP. So there is country code, there is area code, central office or exchange code, and station code. Whereas in E.164 standard, it is country code, same. National code is just a combination of area code and central office or exchange code, and subscriber number is same as the station code in NANP. So just the terms are different, but it is one and the same thing. NANP is the authority. E.164 is the standard followed by this authority. This is one of the example of one of the numbers, 160254592222. One here is the country code, 602 is the area code, 5459 is the central office or exchange code, and 2222 is the station code. Then NANP types of numbers. So different types of numbers which are standard numbers supported by this authority, NANP North America Numbering Plan, are these. We have emergency numbers, local numbers, national and international numbers. The number of digits varies. So emergency numbers can be 3 digits or 4 digits nowadays. Local numbers are 7 digits, national numbers are 10 digits, international 12 to 15 digits. All right. Then, as an overview, the basic discussion, there is DSP. What is DSP? It is Digital Signal Processor. So, what are the role of DSPs? To make calls to PST and DSP is needed. So, a router is used to perform routing to move packets between different locations, which is not equipped with the kind of memory and processor like PCs. Generally, the routers have 128 to 56 MB RAM only, whereas PCs have higher RAM, like 1 GB, 8 GB, 32 GB RAM. So we have to make a router capable of carrying these voice packets. And to do that, we need DSPs, digital signal processors. To move voice packets, router needs to convert a load of incoming voice traffic and digitize and packetize them. For that, the routers have PVDM modules called DSP ports also required for T1 even connectivity. So when we have to connect our edge router to the PSTN, we need to connect it via T1 even connectivity. And for that, the DSP port or PVDM module is required. PVDM stands for Packet Voice DSP Module. And such routers which are inbuilt with the PVDM modules are called ISR routers, integrated services routers. These routers are built in with PVDM ports to add PVDM modules. PVDMs can be used for hardware resource also, for example, for call conferencing, transcoding, etc., which can be done by PVDM ports. PVDM comes in different versions and different number of channels available in that. We have PVDM, PVDM2, PVDM3. The channels available are these 16, 32, 64, 128, 192, 256, 512. Now, we have these different variations of PVDMs available, but why they are used for, not all the ports or all the channels are used for calls only, but some are used and reserved for call conferencing, transcoding also. So if we see based on T1 even connection, if we have a T1 connection, the number of concurrent calls allowed or the channels is 24. Whereas in even the number of channels and the number of concurrent calls allowed is 30. So if we have only a limitation of 24 for T1 and 30 for E1, then what is the use of using PVDMs with channels more than 30 or 32? That is for call conferencing, transcoding, and for other purposes. We can reserve them. All right. Then some protocols used in collaboration networks like RTP. RTP is real-time transport protocol. It works between the IP phones. So it is like when two phones are connecting or communicating to one another. When the call is initiated, it goes to the call manager. It goes to the CUCM or CUCME in some cases. And once the call is being forwarded to the destination then sends the connect messages, and after all the processes have been completed, when the calls are connected between the two endpoints, the parties, calling party and the called party, then the CUCM has no role or the call manager has no role in that. The communication happens by the protocol RTP, real-time transport protocol. So CUCM in that case is just a mediator or the calling manager or the server which is making the communication. But once the communication is successfully built, it just steps back. It's like the referee in the boxing match. It just says, okay, you two now can go ahead and fight. 1, 2, 3, go, and just steps back. Then the referee has no role. It's just the two parties together fighting or communicating in this case. So that's how it works. So RTP is real-time transport protocol. It works between the IP phones in IP networks or VoIP networks. If CUCM goes down, RTP session continues, but the call features will not work like transfer, forward, hold, etc. Now, as the CUCM has no role in this communication, once the two IP phones are connected and communicating to each other, RTP session will continue. But if you want to use any other features during that call, like transfer, which will again go to the CUCM, the request will be sent to the CUCM for transfer or hold or forward, those will not work if the CUCM is down. But the RTP stream, which is already going on, will not be affected. The another protocol along with RTP that comes into the picture when RTP starts running and making communication between the two endpoints is RTCP, which just takes care of, okay, how many packets are exchanged, how many are dropped, how many are successful, how much delay is there, and so on. So just keeping a track and statistics of the call data. So it works along with RTP. RTCP controls, it is a control protocol. It is real-time transport control protocol, and it controls packet count, packet delay, packet loss, and jitter. Now, the port numbers used by RTP and RTCP is this. So it can be 16384 to 32767. This is the range of port numbers used by RTP and RTCP. RTP always use an even port number, whereas RTCP use an odd port number, one addition to the RTP. So for example, if in a communication RTP port used is 16384, so the RTCP port for the same session will be this. It's 1 plus 1. So now we'll discuss about some more components of collaboration solution architecture. So here we can see elaboration of different types of components in Cisco collaboration solution. So here we can see this overview where we have different components of it, like endpoints, we have voice messaging servers, we have telepresence management suite, we have call control managers, IMN presence, CUCM, we have collaboration edge, Expressway C and Expressway E. We have collaboration management services like Cisco Prime Collaboration Deployment, Prime Collaboration Provisioning Server. We have some remote sites. We have mobile or teleworkers. We have third-party solutions, remote sites. Connectivity to these remote sites and third-party solutions can be via internet, MPLS WAN, or PSTN. So just this is a brief overview of the structure and the different components of collaboration. So here is another example of Cisco Unified Communications component. Here we can see we have, let's say, an enterprise here or headquarter, and this is, let's say, a branch. So in the headquarter, we have CUCM, we have a cluster of CUCM, we have CUCM publisher and subscriber, we have a Unity connection, IMN presence server, we have some endpoint devices, different series of endpoints like Cisco 8000 series, Jabber client, we have telepresence endpoints, we have some expressway device, expressway C, expressway E, we have DNS if required, we have cube element, borrow element that we will talk about in this course also. We have firewall for security, for filtering of the traffic. Then we have different types of connections to the branch, internet, PSTN, and IP WAN connections. Then in the branch, we have a small scale solution. So for small scale solutions, we have the alternate options to CUCM, which is CUCM-E, CUCM Express, and CUE, which is a small scale solution for Unity connection. Then we have some clients like Jabber and some IP phones. Okay, so talking about Cisco Unified Communications Manager, CUCM. CUCM is a server-based solution. It has a server, clustered servers. It also uses LDAP for integration, and it communicates with other clusters and gateways. So Cisco Unified Communication Manager is not only a call manager, but it can do a lot more than that. It can provide call routing, it can provide different supplemental services, different types of communication, manipulation, and so on, even instant messaging and presence within CUCM. So it is a framework of different protocols and services involved in it, which it provides in the collaboration network, and it is one of the very important component of collaboration network. So here we can see an example of CUCM. Let's suppose we have a CUCM server here. We have a switch connecting different endpoints. And when the communication between these endpoint needs to happen, the request from the initiator from the endpoint that is the calling party, it goes to the CUCM. Then the CUCM's task to find out whether the destination resides on the CUCM, whether it is registered on the CUCM. If it does, it will send the request forward to the end device through SIP protocol. So the request and response will be through SIP. And once the two parties are connected, the RTP and RTCP are the protocols that makes the communication. If the call needs to go out of the network, then the CUCM will check if there is any gateway. And for the gateway communication, there are different gateway protocols. We have MGCP, H323, and SIP. We will talk about that in this course. And then the gateway takes the decision based on the configuration of the gateway. It will forward the call. All right, so this is just an overview of CUCM, how it works. Then collaboration deployment models. So different collaboration deployment models exist like on-premises, cloud, and hybrid. So in on-premises, all the servers and the management of the servers is the responsibility of the enterprise itself or the organization itself. So you can see the CUCM here, Unity connection, IMN presence, all the different endpoint devices residing on the on-premises. That is an on-premise deployment model. When you're taking some services from cloud, for example, Cisco WebEx or WebEx Team, that particularly is an example of cloud deployment where you are taking these services from the Cisco cloud and not you do not have the hardware on the premises, and the management will be handled by or will be the responsibility of the cloud provider. Then if you have a combination of both, that is on-premises as well as the cloud services. So let's say you have some of the devices and servers within your on-premises and some of the services you are taking from the cloud provider, from Cisco WebEx and WebEx Teams. So that combination of on-premises and cloud is called hybrid. So these are the three different deployment models. Then different licensing models exist. So in licensing, we have Cisco Smart Software Licensing, which are of two types, Cisco User Connect license and Cisco Unified Workspace license. There are different versions of it, like for User Connect, we have Essential, Basic, Enhanced, Enhanced Plus. So based on your requirement, you can see which license you would require. Workspace licensing, we have Standard Editions and Meeting Edition. Then similarly, there is a subscription-based licensing also, which is all-in-one user-based subscription. So like any subscription you get from cloud services providers, same way Cisco provides all-in-one user-based subscription called Cisco Collaboration Flex Plan, which is used for almost all type of services that are required, cloud and premises. It is a subscription, so it is pay as you go. You can grow at your own pace, which gives you streamlined transition to the cloud. Budget operational expenditure is more easier. You can add subscription and services as you go within that. So you can always uh, upgrade or downgrade if you're using a subscription based on the requirement. So this is Cisco Collaboration Flex Plan, which enables seamless transition to the cloud. You can do the migrations, you can upgrade, downgrade, and keep a track of the services being used. And based on that, you can use your Flex Plan. Subscription based, it is from Cisco. You can do different services or functions it can provide you, like meetings, calling, team collaboration, contact center for consistency, flexibility, and value. So here we can see the different advantages or the features of it: meetings, calling, contact center. All right. Then, as we just discussed about CUCM, what is CUCM and how it works, what are the different protocols that it used for making communication between different devices, for making the call control. So, how the CUCM structure is, it is a clustered server. So, in the CUCM cluster, there is publisher and subscriber, which I think we have already discussed also. So, just as an overview or a recap of it, in CUCM publisher and subscriber structure, there is one publisher and how many subscribers?
4.
That is right. In a way, there are 4 active subscribers, but we can have up to 8 subscribers in total. This is the maximum we can have, but 4 will be active at a time. So that is correct. We can add more than 4, that would be fine, that would work, but only 4 will be active at a time. In total, we have one publisher, we have 11 other servers also, and we have 8 subscribers. This is the total number of servers that can be there in a CUCM cluster. So other servers like for IMN presence, for music on hold, and so on for different services separately. We can have only one publisher. We can have 8 subscribers. So we can use like 4 active, which is the maximum active servers or subscribers that a cluster can have, and the rest of them for high availability as backup. So if one subscriber goes down, the other will take over. So this is the total number of supported different types of servers in a CUCM cluster.